Assalamualaikum and very good afternoon to all the viewers. We are from Group 7 of our class and we like to present our group assignment for subject numerical methods and statistics. First of all, our group consists of 6 members and these are the list of our name. Muhammad Nabil is myself, Muhammad Zulfikri, Nik Muhammad Aklan, Vilma Raj, Hari Prasad and Muhammad Ilhan. There are two questions that need to be solved from our assignment and we are here to explain to you guys how do we get all the answers. For question 1, the project objective are quite straightforward, which are to determine the optimal production quantities for smartphone, laptops and tablets to maximize the total profit while ensuring that resources constraints, which are labor hour, raw materials and machine time are not exceeded. Lastly, to determine the optimal production quantities for smartphones, laptops and the tablets. As for the problem statement, the manufacturer of consumer electronics creates laptops, tablets and smartphones, each of which generates different profit per unit. Each item requires a certain amount of work, raw material and machine time to produce. Nevertheless, these resources are not entirely available, as the main objective is to create a linear programming model that respects resources limitation and to maximize the profit.
So for the experiment setup, we extract all the information given from the question, which is the product, which is smartphones, laptops and tablets. The constraints are labor hour, raw material, machine hour and the profit we want to maximize. Next, for the methodology, we want to maximize the profit. So the objective function is P, which is the profit, equal to 2500 S plus 3500 L plus 1200 T. And the constraints, the three constraints, we write such a labor hour for S plus 3L plus 40 equal or less than 800 and so on for the raw material and machine hour. And then we add select variable S1, S2, S3 to get rid of the less and equal sign, and we get only equal sign, such as for the labor hour for S plus 3L plus 40 plus S1 equal to 800. So to solve this question, we use simplex method. So for iteration 0, for the top row, we write SLT, S1, S2, S3, solution and intercept. For the left column, we write P, S1, S2, S3. And we write all the information given. So from this first iteration, the lowest P is negative 3500. So we highlight the column L, and the lowest intercept value is 200. So we highlight the row S2, and then we get the pivoting value, which is 5. So from the previous iteration, we can get this table from by replacing row S2 to L, and the value for L is the S2 all divided by 5 with the pivoting value, and the value for the other rows is the original value minus in bracket new times all L, and then we get this value. We can conclude that the company need to produce 200 L to maximize the profit, which is the 700,000 ringgit.
Thank you, Zulfikri. Now I will explain the result and conclusion for question 1 of our project. Based on our previous method, we compare the result with the Excel solver in data analysis and linear programming model. The optimal production are the same, which is to produce 200 units of laptops and not produce any smartphones or tablet. This combination uses all 1000 kilograms of raw materials, 600 out of 800 available labor hours, and 400 out of 600 machine hours. In return, it gives us a maximum profit of 700,000. From this result, We can conclude that under the current resource constraints, focusing only on laptop production is the most profitable strategy. It efficiently uses all the raw materials while staying well within the limits of labor and machine hours. Therefore, our recommendation to the company is to allocate its production resources to only laptops in order to achieve the highest possible profit. Thank you.
So, our project for question 2 focuses on evaluating how different types of fertilizers affect crop yield. Specifically, we aim to compare the effectiveness of fertilizers under two growing conditions, which is greenhouse and field, and use ANOVA to determine if there is any differences in yield which are statistically significant. We have tested four types of fertilizers, which are organic, synthetic, liquid, and chemical, across two environments. Each combination was replicated three times to ensure its accuracy. The goal is to see whether crop output is significantly influenced by the fertilizer type, the growing condition, or the combination of both. Through this analysis, we hope to identify which factors contribute most to yield improvement. This can help farmers make better decisions about resource allocation, optimize fertilizer use, and ultimately increase the productivity under varying environmental conditions.
Okay, so next, I'll walk you through the methodology used in this study. We tested four types of fertilizer, which are organic, synthetic, liquid, and chemical, under two growing conditions, which are the greenhouse and field. For each combination, we collected crop yield data from three replicates, giving us a total of 24 data points. The response variable was the crop yield measured in kilograms per plant. Okay, so to analyze the results, we used a two-way ANOVA to determine the individual and combined effects of fertilizer type and growing condition on crop yield. Before running the ANOVA, we verified that key assumptions were met, including normality, independence, and equal variance. We set the significance level at 0.05 and all calculations were performed using Python libraries such as Pandas and SciPy.
So as for the results, the grand mean yield is 3.8375 kilograms per plant. The sum of the squares for treatment is 8.99625. For the error, it's 0.16. As for the mean squares, the MST treatment is 2.99875, whereas the MSE error is 0.01. And the F statistics is 299.875. The critical F value is 3.238872. So as you can see, the F statistics is much greater than the critical F, where the F statistics is 299.875, whereas the critical F is 3.24. This means that the fertilizer type and the growing condition significantly affects crop yield. Therefore, the differences in crop yields are statistically significant. The synthetic fertilizers showed that the highest average yield, especially in field conditions, indicates that both fertilizer types and growing conditions have a strong influence on crop productivity. And lastly, as for the conclusion, the study demonstrated that the fertilizer type and growing conditions significantly impact crop yields, with synthetic fertilizers achieving the highest output of 4.9 kilograms per plant in fields. Field environments consistently outperformed greenhouses, and an interaction effect revealed that synthetic fertilizers are superior efficacy in fields. These findings suggest that farmers should prioritize synthetic fertilizers for field cultivation to maximize productivity through long-term soil health and cost-benefit analysis. Warrant further research. That's all from us today. Thank you for watching.